This video is on stationary points and how to find the nature of the stationary points. So we're going to start with an equation, y equals x squared minus 6x plus 11, and this is the graph of this equation. Now I can see the gradient here is negative, and I can see the gradient here is positive, and here I have gradient 0. Okay, so whenever we have gradient 0, that's where the stationary points are. So for this graph, the gradient is 0 here. Okay, now sometimes we're going to be given just an equation, no graph, okay, and we need to find where the stationary points are. Now this is why we can do it. We can start by finding the gradient. So we can say dy over dx is equal to 2x minus 6. Okay, now what I'm going to do is I'm going to set dy over dx. So I'm going to set the gradient as 0. So I'm going to say, okay, so dy over dx should be 0 at my stationary point. Okay, so I'm going to substitute this 0 into here, and I'm going to solve it for x. So I'm going to say 0 is equal to 2x minus 6. Now I can solve this, so I'm going to have 6 is equal to 2x, and if I divide both sides by 2, I'm going to get 3 is equal to x. Okay, and I can see that on my graph as well. When x is equal to 3, I have gradient 0, which is here. Now when the gradient 0, it actually has kind of like a flat gradient. Okay, so the tangent to the curve at x equals 0 is just going to be the equation y is equal to 2. Okay, so it's not going to have any gradient. Now also I can see that this turning point here, or this stationary point, is actually a minimum point. Okay, so for a stationary point to be a minimum point, we need the gradient on the left hand side to be negative and the gradient on the right hand side of the stationary point to be positive. Okay, now we can see this looking at this graph, but how would we do it if we were just working with algebra and calculus? Okay, so let's see how that's going to work. So I'm going to look at the left hand side. So I'm going to say on the left, so on the left of x equals 3, so on the left of x equals 3, I have x equals 2. So I'm going to write x equals 2 here. Okay, so on the left I have x equals 2. Now what is the gradient at x equals 2? So I know my gradient function is here, 2x minus 6. So I can just substitute 2 into here and see what I get. So I have 2 times 2 minus 6. Okay, so this is going to be 4 take away 6. So 2 times 2 is 4. Take away 6 is equal to minus 2. So I have negative gradient. Negative gradient on the left. And then on the right, so on the right of x equals 3, so on the right of this point, I have x equals 4. Okay, so I'm just going to go straight to the integer. I'm not going to go anywhere in between, because then my calculations will be a lot harder. So I'm just going to go to the next integer on the right, so that's 4. So I'm going to say on the right, I have x equals 4. And the gradient here, so dy over dx is equal to 2 times 4 minus 6. So 2 times 4 is 8. 8 take away 6 is equal to 2. So my gradient is positive. So let's say, for example, if we weren't looking at the graph here, what we would now know is the gradient on the left hand side is negative like this, and then we have x equals 3 here where the gradient is 0. So this is where x equals 3, and then on the right hand side the gradient is positive, so the graph will be going up. Okay, so this is in the shape of a minimum point. So we have a minimum point. So a minimum point. So we have a minimum point at x equals 3. Okay, so this is how you would determine the nature of the stationary point. Okay, so first we found where the stationary point was by setting dy over dx is equal to 0, and that's when x is equal to 3. Okay, and we can see that on the graph. And then we looked at the left hand side of x equals 3, which is x equals 2, and found that the gradient is negative, so we can make a little drawing like this. And then we looked at the right where x is equal to 4, and we found that the gradient is positive, so we can make this drawing and see that it's actually going to be a minimum point. Okay, now stationary points can be minimum points. So for minimum points, we're going to have negative gradient, and then we're going to have gradient as 0, and then we're going to have positive gradient. So this is going to be a minimum point. Okay, and then for a maximum, we're going to start with a positive gradient, and then we're going to have a 0 gradient, and then on the right hand side we're going to have negative gradient. Okay, so and that will tell you that it's a maximum point. Now we do also have point of inflection, and this would be positive gradient, then 0 gradient. So positive, then 0, and then positive again. So this is a point of inflection. Okay, and also we can also have a point of inflection like this. So we can have negative gradient, and then 0 gradient, and then negative again. Okay, this is also a point of inflection. Okay, so these are the different things you can find when examining the gradient on the left hand side and the right hand side of your stationary point. So stationary point when the gradient is 0, okay, and then you can examine the left hand side and right hand side and see what you get. Do you get negative or positive gradient? And this will tell you what kind of stationary point it is, if it's a minimum, maximum, or a point of inflection. Okay, so here's another question. We can do this one. So we have a curve has equation y equals x cubed minus 3x squared plus 6. Find the coordinates of any stationary points and determine their nature, showing clearly how your decisions were made. Okay, and sketch this curve. So let's start with the gradient function. So let's find dy over dx, and this is going to be 3x squared minus 6x. Okay, so now I need to set the gradient as 0. Okay, so let's say, okay, when dy over dx is equal to 0, we're going to have 0 is equal to 3x squared minus 6x. So I'm doing this to find where the stationary points are, because the stationary points have gradient 0. Okay, so I can factorize this. So if I take 3x out here, I will have x minus 2. Okay, and this would mean either x is equal to 0 or x is equal to 2. So I have two stationary points, one at x equals 0 and the other one at x equals 2. So I need to look on the left hand side of this and the right hand side of this to find whether or not it's going to be a minimum, maximum, or a point of inflection. So let's see. So on the left I have, so on the left of x is equal to 0, I have x is equal to minus 1. So let's try x is equal to minus 1. Okay, and my gradient function, I have it here. So 3 times x squared minus 6x. So I have, so the dy over dx here is going to be 3 times minus 1 squared minus 6 times minus 1. Okay, so this is going to be 3 here, and minus 6 times minus 1 is plus 6, so plus 6 here, and this is going to be 9, so I know this is going to be positive. So on the left hand side, the gradient is positive. Now I'm going to look at the right hand side of x is equal to 0. So I'm going to go to x is equal to 1. So on the right hand side, I have x is equal to 1. Okay, so let's find the gradient here. So dy over dx is equal to 3 times 1 squared minus 6 times 1. So 3 times 1 squared, that's just 3, take away 6, which is equal to minus 3. So I have negative gradient here. Okay, so this is negative gradient. Now, so I can draw a little diagram now. So I have on the left I have positive gradient, so I'm going to have positive gradient, and then I have, this is where x is equal to 0. Okay, so I have positive gradient there, then I have 0 gradient, and then I had negative gradient. Okay, so at x is equal to 0, we have a maximum point. Okay, now what I'm going to do, because we needed to sketch this graph, I'm going to find what the y value is when x is equal to 0. So I'm going to find the coordinates of this point. So let's find that. So we got y is equal to, so y is equal to x cubed minus 3x squared, and then we had 3x squared plus 6. Okay, so 3 minus 3x squared plus 6. Okay, so when x is equal to 0, we're going to get y is equal to 0 minus 0 plus 6, which is equal to 6. So the coordinates of this point is going to be 0, 6. Okay, so we're going to have to remember that. Okay, so that's going to be a maximum point. Now let's try the other one. So the other one is when x is equal to 2. So I need to go to the left of that and right of that and see what the gradients are. So on the left of that, so on the left of x is equal to 2, I have x is equal to 1. Now I've already found the gradient for that, and it's negative. So I'm just going to say dy over dx here was equal to minus 3, and we have negative. And then we're going to go to the right. So to the right of x is equal to 2, and that will be x is equal to 3. So let's find dy over dx, and that's equal to 3 times 3 squared, take away 6 times 3. Okay, and this is going to be 27, take away 18, and that is equal to 9, and this is positive. Okay, so we have positive gradient here. Now let's draw a diagram. So on the left we had negative gradient, so it came down on the left. So we had negative gradient there, and then at x is equal to 2, we had 0 gradient, and then we had on the right we had a positive gradient. So this is going to be a minimum point. So at x is equal to 2, we have a minimum point. Okay, so now we know where the stationary points are. That's at 0, 6. So 0, 6, we have a maximum point. Now we need to find the coordinates of the minimum point as well. I know the x coordinate is going to be 2. Let's find the y coordinate. So we have y is equal to, we have 2 cubed minus 3 times 2 squared plus 6. Okay, I have the equation here as well, so I'm just substituting 2 into here. So that's going to give me 8 minus 3 times 4 is 12 plus 6. Okay, so this is going to be, so 8 add 6 is 14, take away 12 is 2. So it's going to be 2. So the coordinates of this minimum point here, okay, so the coordinates of this point here is 2, 2. Okay, so we need to remember this one as well. Okay, so let's start drawing our axes. So we'll draw some axes here. So let's have our y-axis. Okay, and the x-axis. Okay, so I know two of the points. I know the 0, 6. So 0, 6 is going to be here. And I know that this is going to be a maximum point. So I'm just going to start making a drawing like that. So it's going to, I'll do that again. So it's going to approach it like that and then leave it like that. And the other point I know is this point here, 2, 2. And I'm going to have a minimum point there. So let's go back. So a minimum point at 2, 2. So let's say the point 2, 2 is around here. Okay, so this is the point 2, 2, and that was the point 0, 6. Okay, and at this point here, I'm going to have a minimum point, so it's going to have positive gradient leaving it. So I can see that it approaches like that, and then it leaves it like that. Okay, and also this, because it's a cubic curve, it's going to come through like that. Now this one is quite difficult to solve this, because when we set y is equal to 0 here, this is very difficult to factorize, and there aren't any integer values that you can use here that will give you 0 when you try the factor theorem as well. Okay, so this one we don't need to give, but we need to say that this is the point 0, 6. Okay, and I can see the y-intercept is 6, and we need to say that this point here is 2, 2. So we had a maximum point here and a minimum point there. Okay, so last thing, you have some questions here to do. Okay, so one full question, okay, ends with sketch the curve. Okay, so you have this equation, follow all the steps, okay, the whole process, and then you end up sketching the curve. Okay, so do this question and then bring that to the lesson.